What if a country of just 6 million people is about to redraw Europe's energy map from the middle of the sea? Denmark is spending $30 billion to build an artificial island 80 kilometers offshore, not for housing, but for power. In a decade defined by climate shocks and energy wars, this project could decide who controls Europe's green future. For centuries, the North Sea meant Vikings, trade routes, and later oil and gas wealth. Today, Denmark wants it to become the electrical heart of an entire continent. The idea is radical. Instead of running longer cables to distant wind farms, build land in the middle of them. This energy island will collect electricity from hundreds of offshore turbines and redistribute it across Europe. Traditional offshore wind farms lose efficiency the farther they sit from shore due to transmission limits. High-voltage alternating current suffers heavy losses over long submarine distances. Denmark's solution is to centralize generation, convert power on-site, and export it efficiently using HVDC technology. The island becomes a massive electrical switchboard, a green version of an oil terminal. In its first phase, it will support around 3 gigawatts of capacity, enough to power millions of European homes. But this is only the beginning. The blueprint allows expansion to 10 gigawatts. That scale would rival large conventional power plants, yet fueled entirely by wind. Before a single electron flows, however, engineers must solve a far more brutal problem: how to build permanent land in one of the world's most hostile seas. To survive the North Sea, engineers must first create land where none exists and make it permanent. The chosen site lies in waters 20 to 50 meters deep, shallow enough to build, violent enough to destroy. The foundation will rely on massive caissons, hollow concrete structures towed out and sunk to form a defensive ring. Once anchored, these chambers are filled with sand and rock, transforming open ocean into solid industrial ground. Surrounding seawalls must withstand rogue waves that can rise as high as multi-story buildings. After the civil engineering comes the electrical core, high-voltage direct current converter stations. Wind turbines generate alternating current, but AC loses power over long submarine distances. On the island, that AC is converted into HVDC, minimizing losses across hundreds of kilometers of cable. This hub-and-spoke architecture turns scattered turbines into a unified offshore power plant. Each turbine will stand nearly 260 meters tall, approaching the height of the Eiffel Tower. Hundreds of these giants will circle the island to reach the initial 3-gigawatt capacity. A single full rotation of one turbine can generate enough electricity to power a household for days. The island will also function as a logistics base, with harbor access, helicopter pads, and on-site crews. Eliminating long daily boat journeys cuts operational costs and increases uptime in harsh weather. But electricity alone is not the real revolution. The real gamble begins when Denmark turns wind into fuel. The real breakthrough is not electricity, it is chemistry. Renewable energy has a fatal flaw. The wind blows when it wants, not when markets demand. When grids are full, excess wind power is often shut down, wasting potential energy. Denmark's answer is called Power-to-X, turning surplus electricity into industrial fuel. On the island, massive electrolyzers will split water into hydrogen and oxygen using wind-generated power. The result is green hydrogen, a zero-emission fuel that releases only water vapor when used. Producing hydrogen at the source eliminates the need to transmit every kilowatt back to shore. But hydrogen is difficult to transport, requiring compression or extreme cooling. So engineers convert it further into green ammonia or e-methanol, liquid fuels easier to ship globally. These fuels could decarbonize heavy shipping and aviation, sectors batteries cannot realistically power. In effect, the island becomes a floating refinery for the post-fossil fuel economy. Strategically, this transforms Denmark into a green energy hub linking Belgium, Germany, and the Netherlands. Interconnected undersea cables create a multinational power bridge, strengthening European energy security. Yet concentrating infrastructure offshore creates new vulnerabilities: storms, sabotage, cyberattacks. Denmark's $30 billion gamble will determine whether the North Sea becomes the fortress of a green era or the world's most expensive experiment.